Hello, how are you? So in this video, we are going to create a 3D product configurator, but in Angular. Now you would have seen these product configurators on the web. Product configurators are basically 3D visualizations of your product, which you can allow the user to change at runtime so that they can order a specific version of your product. So in this, for example, case, which we are going to build in this tutorial, you can see that we have a nice looking mug here and it's rotating just like a product would. And then you can change the colors here to select the color that you want, which is suitable for your needs. And then hypothetically, you can click on add to cart and you can order this specific product here. All right. This is a nice way to market your product and allow the users to customize your product. And you can use any sort of model here. There are just limitless possibilities. But such a kind of experience was difficult to build before in Angular. And the reason was that these experiences are mostly built using 3.js. Now, 3.js is a JavaScript library which can be used with vanilla JavaScript. And it basically abstracts out a lot of stuff with the WebGL standard, which is used to render 3D experiences on the web. But 3.js has a lot of boilerplate code to set up. So all major frameworks have a sort of wrapper around it. But Angular was missing in that aspect until Chao Tran, who is an open source maintainer and who is an Angular enthusiast and also a Google developer expert, he actually started work on this quite a while ago. And recently he brought out the latest release, the Angular 3 version 2 release, which actually is compatible with all of the latest Angular features and is compatible with the latest Angular version 18. So now it has got much easier to create experiences like this. And now Angular developers can also use the simple declarative syntax which is present in React 3 Fiber to create such things in Angular. So how do we create such a 3D visualization in Angular now? I'm going to show you exactly that in this video tutorial, and we are going to use Angular 3 version 2 as I said, and I'm going to use Tailwind CSS for all of the styling here. The code for this app is available on my Buy Me a Coffee shop, from which you can get it right now even if you just want the code. All right, so let's get started. Okay, so let us start with a basic overview of the project that we'll be working with. So our project is, as you can see, it's Angular version 18, the latest Angular version, and it uses Tailwind CSS for our styling. And our starting point here will be this layout. So we have some layout on the left side here. It's some simple HTML with some styling. And we have a simple button here, which is not working at this point, but you can hook it up later. And then we have this component here. So if you go in the code here, you can see that we have product info and we have the button, and then we have this app color options. Now this is a component which contains a list of colors, and we are rendering them as simple swats so that we can select the color of our product, in this case the mug. And then we are changing the color in a config service. So I'm using a shared service to communicate among the 3D scene and among the selector here, the color selector here. Okay, so let me show you the service here as well. So the config service, you can see it's very simple. There's just a simple set color function and a signal that we can use to share the state. All right, great. So simple enough. Now on the right side here, this is where we are going to have our 3D scene here. Of course, before jumping into it, we also need to create our 3D model, or we can get the 3D model from somewhere. Now, so because I am not a 3D modeler myself, and chances are that you are not as well, you can get the 3D model from a lot of different places on the web where 3D models may be available for free or for a price. I've used sketchfab.com to get a 3D model of a cup, which I really liked here. So you can see it's a cup of coffee. It's by David Spechy here. All credits to him for this model. And you can go on Sketchfab. It's freely available, but it does require a bit of attribution. So I'm just crediting the creator here, and David Spechy, under the Creative Commons attribution license. Okay. And from there, then you can use this GLTF file format, which is basically a file format where we can bundle a scene, a 3.js scene together so that we can import it in other apps. So Angular 3 also provides the same support as 3.js provides for loaders. So we are just going to click on download here and download this in our app. Okay. And then we're going to copy, there will be two files, and we can copy these two files in our assets. So you can see that we have cup.gltf here and scene.bin, which these two files are basically needed to load the model itself. Okay. So once we have copied this, now we can actually go towards importing this in our app. Okay, let's first then start by installing Angular 3 and how easy it is. So what we're going to do is we're going to use the schematic provided by Angular 3. And if you go on its documentation site here, Angular 3, you can see that we get this in getting started here, installation. So you can see that this is the easiest way to install Angular 3, ng add Angular 3 here. So we're going to do ng add Angular 3. And of course, my package was already installed because I've already tested this, but it gives the option to generate an experience component. Now, an experience component is a sample component. There's a sample scene that they provide. The library provides so that you can get started doing that. So let's generate an experience component and see what it does. Great. So now when we go in our app component, you're going to see that it created an NGT canvas here and it created a scene graph, and then it's linked that scene to our experience here. Okay, so this is our basic scene that they have created. So let's just copy this canvas, NGT canvas component here inside of the section that we have, the 3D section that we want our product to have. And let's just see how this looks. Great. So now you can see we have a basic scene all set up. So this schematic is really a nice point to start working with Angular 3.js. All right, but we obviously don't want this. We want to load our own model. So let's get into it and let's start doing our work. So if you can see here, you can see that the basic building block of this is the canvas component, and this NGT canvas component has to be imported in your app component or whatever component that you want to import it to. This is the building block of this and contains all of your 3D scene. And then it contains an input called scene graph. And in this scene graph, you need to pass in a component which will contain all of your scenes or your whole 3D scene. It can have nested components as well. So it can be as complex as you want it to be. So this scene graph is then inserted just like this. And you can see that we have experience assigned here and imported from this. Now, if you go in this component, you will see that it does not have a selector here because we don't use it by declaring in the template, but we just send it as an input to the NGT canvas component. And you can see it has some basic components here. Okay, so a bit more about this scene. Let's go through this. So this NGT mesh and NGT box geometry, basically, they are custom HTML elements. So these are not like Angular components or directives. They don't need to be imported. So these are custom HTML elements which directly correspond to 3.js objects. So NGT mesh basically corresponds to the mesh object. NGT box geometry corresponds to the box geometry object in 3.js. So there's a direct sort of mapping to it. But to use this, we just have to use custom element schema, which we can import from Angular core. And this is because in Angular, we actually need to specify this in schemas to get custom HTML elements to work. All right. And at the top here, you are going to see that we have extend and mesh box geometry mesh basic material. So this is a way to include only the custom elements that you want to include. We're going to replace this with the whole namespace from 3 so that we can get all of them for the purposes of this tutorial. We don't have to change things again and again. So we're going to just extend all of them so that we can get the whole namespace available for us. Okay. So these are sort of the basics to get working with a scene in Angular 3. And let's now start building this up. Okay, so we're going to start with loading the model, which is the logical step. So we are going to remove this, all of this here. And we are first going to clear all of this from here as well. And we need to use the GLTF loader for our model here. So what we're going to do is that we are going to use a function called inject loader. So we are going to assign GLTF to a function called inject loader. And this takes 2 arguments. The first is basically the type of loader that we want, because we can load different types of files in 3.js. So what we want to do is we want to load GLTF loader here. Now this loader actually we need to import from. So we're going to do 3 examples, JSM loaders and GLTF loader here. And we're going to do here GLTF loader. Okay. So we specified the loader here. And then the second part would be the path that we want to get the file, the GLTF file from. So in our case, it is assets/cup.gltf. Okay. Now this is going to inject loader is going to return a signal. So we can then use that signal to actually render the content on the screen. So first, we want to add some checks to it so that it's not null. So we're going to create a computed named model derived from this. And what we're going to do is we're going to add some logic here, like we're going to do GLTF is equals to this.gltf. And if GLTF is null, then we can just return null. But if it's not null, then we are going to return gltf.scene. Now, scene is basically the top level object group that usually is there in GLTF and which we can use to render the whole model on the screen. Now, if you want to render a model, an external model, we can use the NGT primitive custom element. All right. So we're gonna create NGT primitive, and then in NGT primitive, we want to give some arguments. Now, for any custom HTML element in Angular 3, we can give two types of arguments here. So first is the constructor argument. Now, if I show you the 3JS documentation here, and you can see here that this is a light object here, you can see that it has a constructor here. So if you want to pass in parameters to the constructor, we are going to use an argument structural directive provided by Angular 3. And to use that, we need to import it in our imports here. So let's add some imports here and let's do NGT args. Okay. And we need to give this model inside of these args structural directive here. And it just takes the array with the constructor arguments one by one. Now, NGT primitive is not really a 3JS object, but the same pattern is followed in all of the custom HTML elements. So I'm specifying this here. All right. So in this args, we are going to send the model here, the value of the model here, which is the scene, the object scene that we have. All right. So this is the first type of meter or first type of inputs that we can give to any custom element that we can use in Angular 3. The second one I'll mention in a bit, but let's see how this looks now. So now if we save this and we look at our app here, you can see that we have a very black looking, it looks like a cup, but it doesn't have any 3D, it doesn't have any color, it doesn't have any 3D depth to it. And that is because we haven't set up the scene correctly. And for any 3D scene to render correctly, it needs some lighting. So to set up some lighting, we're going to add an ambient light first. So we're going to use NGT ambient light. Now these are all directly mapped to 3JS elements. So you can directly use those with the NGT as a prefix here. All right. And let's save this and see. And you can now see, we can see some color, but the ambient light is basically just a basic light flowing in all directions and it does not cast shadows. So it's not going to give us that 3D look that we want. So we need to add some more lights, but first we also need to pass in some parameters to this NGT ambient light. So you remember I told you that these static arguments are used to send constructor arguments, constructor parameters. But what if you want to change the properties of this object? So for these, you can just use simple inputs just like you do in normal Angular components. So here, for example, if you go in the light here, and since we're using ambient light, all lights have this structure. So you can see the properties have an intensity property. So we're going to change the intensity of the ambient light to be 2 here. And let's see this. And you can now see that it's got a bit brighter. All right. So this is fine for now, but we need to add some 2 more lights. In fact, 4 more lights. So 2 of the lights I wanted to be NGT directional lights. So these lights have a direction, so they cast shadows. They have an intensity of 2 here, and we can also specify a position. So I specified some different positions for it. Now you can play around with these as you want. I have already tried and tested it. Through trial and error, I found out these values. So I'm just going to save this and see how this looks. And now you can see that it does look a bit better here. It looks a bit more shiny. So we can just change the ambient light to 1 again so that it becomes a bit better. So you can see now it looks closer to the cup of coffee that we saw here. So this is sort of the original color of that cup model that we saw. Okay. But you can see that it's too far away. So we need to change the camera zoom a bit. So let's first update the camera zoom. And to update the camera zoom, we need to change the camera properties of the NGT canvas here. So we're going to do camera and we can simply change it in the parameters here. So we're going to specify zoom as 4 and let's see how this looks. And you can see that it has zoomed in and it has come really closer. But you can also see that we can't really see the whole cup now. We need to reposition the scene itself so that we can see the whole of the cup here. So what we're going to do here is then we're going to go in our scene here and we're going to, for the NGT primitive, I'm going to give a meter here position, and in the position I'm going to set in some values here so that we can position this correctly here. So I'm going to give it 0, -0.7 and -0.1. Now these I came through trial and error, and it will depend on the type of model that you're using and the original position of that model in your scene. So if you now see, you can see that we have at least the cup modeled in the center as you want it to be. All right. We want to change its sort of initial position of the camera so that it sort of appears on top of the cup so that we can see the top of the cup as well. And that's just a nicer visualization than it currently is. So I want to go in the camera here and I'm going to make some adjustments here. I'm also going to pass in a position here, and this position is going to be 4, 2, and 1. Okay. And let's see this. And now you can see that it looks much more like a normal product display. And now you can tweak around with these values and you can change the camera positions, zooms, and the positions of the object inside of the scene. And you can change it to your own liking. All right. So this just looked suitable to me. Okay, so this looks fine. We need to add a bit more lights to it, and I'm going to add 2 more lights to it. So I'm going to add a point light to it as well. NGT point light. Now point lights are lights which emanate in all directions. So they're a bit different from the directional light. Now for these, I'm going to give the intensity as 0.5. I want to keep them light. The position here would be then minus 0.5, minus 0.5, minus 0.5, and 0. All right. So let's see how this looks. And now you can see a bit more sort of point lights on this, which looks more like a studio product. Okay. So this model visualization looks good. Now we want to add the customization of its colors. So how do we do that? Okay. So to customize the color, we need to find out what we need to change exactly. So to do that, we first need to inspect the whole scene and the object. Since this is a custom made model by someone else, we need to find out the structure of it and change the specific color of the material that we want to. So to find that out, what we're going to do is we are going to, in the model that's returned here, we're just going to do a console.log and then inspect it to find out where we want to make this change. So we're going to do gltf.scene here and let's save this. And now you can see here that we get the group, the 3D group object here, which we can inspect. And now if you go in the children here, you're going to see that there's an object here, object 3D, and then in the children here, you're going to see another object. And then in these children, you can see there are 2 meshes, which basically represent the outer mesh and the inner mesh of the 3D mug here. Now, so for this first mesh, this is actually the material that we want to change. Now, if you don't know a bit about 3D, so in 3D, you have a mesh, which is the structure of the 3D model, and then you have a material which represents the visual look and feel of that 3D model. So you can see that we have a mesh standard material attached to this model here, and then when you go in color here, you can see that you have 00 R this as well in RGB. So we want to change this color actually, and let's just try this out to see if this is what we want to change. So when you change the blue here, you can see that the color here changes. So this is exactly what we want to change here. So how do we change that and how do we get that? So we first need to see what this object this is. So you can see that the name of this object is object underscore 2. Now this is going to differ in your own model if you are taking some other model from some other source. So you need to inspect it in this way. So we need to get this object underscore 2 and we need to change its materials color. So here we are returning the scene and we can actually get the color from our config service, the latest color, and then we can change the color of this material right before we return this scene model here. And that is going to ensure that we always get the latest selected color. And it's going to be dynamic because it is a computed and it's going to change whenever the GLTF changes or the color changes. So first we need to import the config service here. So we're going to do config service, inject the config service. Let's get the color here from the config service. So we're going to do this .config service .selected color. And then let's get the object that we want. So we're going to get the mesh here. And this mesh is going to be gltf.scene. And there's a function in 3.js which we can use because underlying all of these objects are coming from 3.j. So we can use any functions there. So we're going to use get object by name. Now this function gets any nested objects in any hierarchy in that 3D scene. So we can we don't need to traverse it in a very difficult way. We can just get it by the name. So we can do object underscore 2 and this object is going to be then mesh, and this mesh is already imported from our 3. So you can see that our types are all covered. And now we want to get the material for this. So we're going to get the material for this as mesh dot. We're going to do mesh standard material for this. Let's import this from here as well. Okay. And now what we need to do is just we need to update the color and we're going to do material color dot set and we're going to create a new 3JS color here. So let's import it from, in fact, let's just remove this and let's just add it to the imports just like we did for that. You can see that it adds import here, the color. and then we just pass in the hex. So this is a constructor argument that we need to send to the color to create this color. All right. And now since we have changed this scenes material here, we can just send that back and it's going to get updated. All right. Simple as it is. And let's just save this and let's see how this looks. So now you can see that our color has already changed because the first color selected was this and the second color is blue and all of the other colors we can change it like this. Great. So our dynamic 3D scene now works perfectly. Okay, now all that's left is to add some finishing touches so that our 3D scene becomes a bit more interactive. Now you can see that we can't actually change anything on our scene and the rendering is basically very rigid here. We can't rotate it around or we can't do anything else to it. So how do you do that? Now 3JS has a lot of utility libraries along with 3JS itself, which facilitate this process. So we can import those libraries, and Chow has provided ports of all of those libraries as well, so we can use them. So one of them is 3D STD Live, which provides an orbit controls, which we can use. So we're going to install 3STD Live first. So npm install 3STD Live. Great. It's installed now and we can now go and import that here. So let's import that from here. Import this from 3STD Live. And what do we want to import? We want to import the orbit controls. Now, since this is apart from the 3JS namespace, we want to also add an extent here to include that. So we need to give orbit controls here as well. And now we can use NGT orbit controls as a custom HTML element in our template here, just like we would do any normal Angular component. So we're going to do NGT orbit controls. And now for an orbit control, it takes two constructor arguments, which we need to send it. And if you look in the 3JS documentation, you can see that we have orbit controls here. It takes two parameters here. The first is the camera, which we want to control. And the second is the DOM element in which the 3D scene is rendered. So we can get these two things by using a utility sort of state or store provided by Chow in Angular 3. And we can do it like this. So let's import that here along with the service. We can do NGT store. We can inject store from Angular 3 and then we can get the camera from there as well. So we can get the camera, this dot NGT store dot select. The select function is used to select specific bits from the 3D scene that we want. So we can use the camera here and then we want the GL DOM element. So this dot end select and we can get GL and we can get nested sort of objects as well. So we're going to select GL DOM element. Okay. And then we're going to use the same static arguments structural directive to pass in the constructor arguments. And let's pass in here. So the first will be the camera. Since it's a signal, we want to pass in the value and then GL DOM element, the second one, which will be the signal here as well. Okay. So let's test this out. And when we save this, go back to our 3D scene, you can see that now we can use our mouse to actually rotate stuff and we can zoom in and we can zoom out as well. So now we can check out a 3D view of our 3D mug. Awesome. Let's add a bit of parameters to it so that we can make it a bit better. And we want it to be auto-rotating. So we can pass in some properties to it. First of all, we want to disable the zoom. So let's enable zoom false here. Okay. And then we also want to enable auto-rotate, which is a property which is going to rotate this automatically around its axis. And then we have a speed option here as well, which we're going to specify to our value of 5 here. Okay. But when we try this out, we can see that we can't zoom anymore, but we see that it's not rotating. And that is because we're not actually updating the orbit controls in the animation loop. Now, what happens is that when Angular 3 sets up this ngtcan component, it also sets up a render loop so that we can render animations using request animation frame behind the scenes. So to change things on each render frame, we can use a function that Angular 3 provides, and that is called inject before render. We need to provide it in the constructor here. So let's create a constructor here for the class in the scene. And in this, we're going to specify inject before render. So if you want to animate anything, this is the best way to do it. But in this case, we don't want to animate. So we just need to update the orbit controls on each of them. But to do that, we also need to get the orbit controls in our template. So we can use the view child decorator here. So let's say we do orbit controls and we can also give here a template variable called orbit controls. So here we can use the new view child signal based view query, and the type here would be element ref, but within this element ref, the type will be orbit controls. Okay, and the selector will be orbit controls like this. All right. So now in inject before render, we will get our object signal because we want to get the value, and we're going to get the native element. This is going to give back our orbit controls. And if we have the orbit controls, we just want to call the update function of orbit controls here. Okay. So now if we save this, now you can see that our cup is rotating nicely here. Now we can stop this rotation and rotate it ourselves and see wherever we want to see. But when we leave this, it's going to start rotating again. Great. So our product configurator looks really good, and this is good enough for this tutorial. But you can continue tweaking this and continue changing the properties of this 3D scene, or changing the lights, or even updating the model if you'd like to, and add more customization options. The sky is the limit in this case. Now, admittedly, this is a very simple example, but this shows you the bare bones of how to set up a simple scene from an external model and modify some parts of it. But if you want to look at more examples and you can create a lot of different complex 3D experiences with this, you can go to the examples ported here by Chao himself from React 3 Fiber. So you can see this awesome example here. For example, it has reflections and all set up. And then you can see this example here, which is a 3D model walking. And then you can see this example here of a donut here. And there are also other examples which really make your jaw drop. See this simple example. So anything you can do with 3JS and React Fiber, you can do it with Angular 3 as well. And Chao has designed the library in that way. So a huge thumbs up to Chao for coming up with this and finally releasing this as well, the version 2, because we were missing this. Those who were into 3D were missing creating these things in Angular. Now, in my future videos, I'm going to cover more such 3D experiences. So watch out for that. As before, if you want the code, it is available on my BMC shop and you can get it from there. Whatever support you provide there, it's going to help me sustain this channel so that I can keep creating more content like this. If you like this video, please hit the like button and also make sure to subscribe to the channel so that my videos can reach more people and benefit the larger community. Thanks for watching, and I'll see you next time with another interesting video.